Now we're going to be moving into testing applications. And the first thing you want to think about with testing is correspondence. It's not a matter whether we can develop specific qualities or attributes, right? Making someone stronger or faster is a unnecessary thing if it doesn't equate to performing at a higher level. And I know these are benchmarks that we pride ourselves on as strength conditioning professionals, but one thing I want you to establish as we're looking through just different forms of training in general is this idea of breaking this metaphorical box that we put ourselves into, that our value prop is more than just associating with developing certain attributes like running faster or jumping higher. And again, going back to the truth of the matter is that's going to be a big weight on our influence on our environment. And I'm not trying to discredit that or diminish the value of that, but if we limit ourselves to just that, that therefore limits the inventory of things that we may be able to do and maybe just create some sort of myopic focus on erroneous and unnecessary things. And I want to be very clear that there's a blend of, okay, I need to associate, I'm developing athletes that are playing a sport and their job is to leverage whatever we're trying to do within the weight room or during sprint work or conditioning work or just general physical preparation, that it has to apply to something greater than that actual activity, right? The process is a reflection of what we want from an outcome. And the process isn't the destination. The destination is performing at a higher level, being more resilient, being more capable, being more prepared. And the other end of it is the don't get into the trapping of none of it matters, right? The equal opposite perspective is that, hey, the best players in the world don't resistance train or don't utilize stuff. And I think that's another like trap, right? It's like somewhere in the middle, and this is blend of there's folks that really definitively have a higher need for strength conditioning, and there's folks that maybe can get away with a little bit less, or they're just incredibly skilled or incredibly talented and maybe have a lot of innate ability. They're always going to have some sort of inherent benefit. It's just this certain weight effect that we have to attribute to that. But that goes into that like narrowed box of traditional gravity-based strength training. And when we start to do test prep and our whole world is based off improving or enhancing certain attributes within the weight room or on the field that's essentially gravity based, you start to lose sight of the real ultimate purpose, which is correspondence. Which goes into, all right, well, let's start to look at a profile, right? Let's start to look at not only just strengths, but weaknesses and start to think about, okay, where this person falls percentile, relatively speaking, to maybe the best in the world, the best in your league, the best on your team, or the best in that position group. And you start to associate, okay, well, where's the gap? And then it creates an ability to assess and appraise your programming, right? So if you see a pattern of gaps, like let's say that your team is historically slow. And one of the graphic I'm showing you here now, in terms of speed, strength, capacity, body comp, and power, those are kind of the big 5 attributes that kind of make a difference. And again, I'm more than just those big 5, but as I start to break down that spider chart and say, okay, where do they fall percentile wise, relatively speaking to that team, the league, the best in the world, the entire sport, you can start to maybe associate, all right, well, there's going to be blind spots in my programming if I don't address it. Or let's say that my team is awful body comp, or let's say that my team has awful work capacity, like relatively speaking to the league. And the big fish, small pond, getting them into a big blue ocean, all these things have some sort of relativity to it that you start to associate with my program's going to be inherently flawed, right? The classic line of all models are wrong, but some are useful. I think that's the same thing. Your program is as good as it possibly can be for the environment it needs to be until you realize that there potentially is a greater, bigger, more elaborate way to evaluate and interpret your program. And that is a really big gift that you're going to get right here through this course. And if it leads to you getting a flywheel, great. If it leads to you looking into different forms of resistance or getting more multi-planar, multi-vector work into your programming, working through different contraction types, trying to really understand how to create a robust, resilient, capable athlete in a more holistic way, that's equally, if not more important. So let's start to look at, things like KPIs and establishing that, right? I always go through, generic prescription, right? If you really want to evaluate my program, it should be effectively evaluated through my best and my worst, like the outliers, and then the overall median and the mean, right? The middle of the group and then the mean and the average. And if I look at those like kind of classic statistical models, and you can look at things like p-values and other things that look at with the statistical significance of what that testing showed or that output metric showed, you get into this dynamic of correspondence is hard to evaluate and objectively say whether you're doing a great job or not. And that's frustrating. And I could lead that totally down the road of like, if it's hard to define what I'm doing, or if it's hard to articulate what something I might be doing from a training tool or a like piece of equipment like a flywheel, it becomes harder to associate that's a value or that's something that's directly tied into it. And I can totally empathize with that feeling of maybe imposter-like syndrome of, hey, I don't really know a whole lot about this, and I struggle to conceptualize how this might apply to my setting or how I can justify getting on a table and talking to administration or paying for out of pocket or whatever I have to do to get this thing in my facility, because it's abstract. I don't really fully grasp it, and I got to work through that process of doing that. And I'm not just trying to just change to change. I want to make sure that it has a tangible, and that's smart. That's doing your due diligence. But at the end of the day, if we start to look at the actions that happen in chaotic environments like a team sport, a lot of it mirrors what's going on with the flywheel, with momentum, angular velocity, all sorts of different multiplanar, different multi-vector, different rates and change of rates and forces and overall things that might happen that really don't get from a traditional barbell gravity-based resistance. And yeah, it's leading into developing attributes, but then you start to think of those attributes aren't as correlated to success as we would like, or corresponding to success as we would like. And you start to see the naysayers think, okay, well, that strength training is unnecessary. And I think we've kind of passed a certain point as a profession that we've proven or justified the utilization of certain traditional time-tested proven methods of strength training. And you should be the one that's most critical of that and always evaluating. This isn't the unified theory of training. I haven't created a universal solution to everyone's problems. No one ever can do that. But you start to think about, okay, well, what are the gaps here and what are my limitations? You should be more aware of what's not corresponding to their performance more so than anyone else in the world, because you're the one who's critiquing and being as critical of what you're doing as humanly possible. So let's start to break down the things that you want to think about if you start to introduce a flywheel into your setting, right? So we know that like, hey, a traditional barbell or gravity-based resistance training is going to be progressive overloads. There's three forms of progressive overload. We can look at it from intensity, trying to increase weight. We can look at it from volume, increasing sets or reps or time retention. Then we can look at it from intensity. I'm either going compressing, where I'm trying to do the same work in less time, or expanding, I'm doing more work in the same time. And that's your gold standard of gravity-based resistance, right? That adaptation mark is predicated off of, did I increase in something from 1 week to the next over a series of weeks in a mesocycle? And that's intuitive. It makes sense. It's easy to explain. It's associated with success. It's associated with this optimal frequency, work to rest ratio density within a training session and a microcycle that leads to positive adaptation. And if we look at different models like fitness fatigue, just essentially looking at adaptation rates in a multivariate environment, you start to look at it from, it's nice, it's clean, it's easy to go. Progressive overload is a really valuable thing I can build off of my programming and the success there of it. But on the other end of it, which is mission critical, you're probably detraining eccentric strength, maybe even isometric strength. You're probably not addressing different planes of motion and different vectors. You're probably not working through different momentums, different inertias, different velocities. And the truth is that, we're probably creating these like inherent weaknesses from our programming from not addressing these issues with our resistance, because it's just so easy to articulate what we're getting. But we're looking at intensity of flywheel, going off of what I just explained, intensity with gravity-based stuff. It's velocity that we're looking at, or the lack thereof. So it's the rate of movement, right? Velocity, that force over time, kind of that breakdown. And if we think about that correlated to inertia, so inertia is that angular momentum and angular velocity. And momentum is this, as I describe in physics, like this oomph, like how much is going in that direction, right? So it's in a lot of ways this connection to inertia that you can think about in terms of, all right, well, that thing. And there's a metaphorical aspect to inertia as well. If you really want to break down inertia, is that tendency to stay in that state, that either state of motion or state of static. And when we look at inertia or breaking inertia, and we look at the concepts of momentum and velocity, specifically angular, which is a concept that you need to work through because the diameter of the wheel has a big impact on the amount of inertia or the lack thereof inertia, and looks at the rates of which you can move. But if you look at the intensity, the size of the wheel, it comes in like a small, medium, large, XL. That's kind of like a nondescript way to describe intensity, right? So if you're like programming it, like, all right, we're going to use a medium wheel. You could disassociate with that and just strictly look at velocity. And the best way I could describe this is thinking about if you're using VBT and you're setting with barbell. And instead of saying, hey, I don't really care about the weight of the bar, I just care about the intensity. Now, we want to be able to associate the intensity of the bar with the rate in which we're moving so we can create some sort of power metric. But in Flywheel, the diameter of the wheel is probably, it's more abstract and it's less like correlated to progressive overload as you might think. So you have to kind of reframe this. And your biggest thing is looking at is how fast or how slow is it moving? What's the velocity of the rate? And then you start to associate, as we'll talk through, the volume of the distance from that actual center of rotation, the amount of duration or total number of reps we're doing as the other component. So it's going to be a lot in terms of velocity and work, because we can easily quantify that when we're looking at something like isoinertial or a flywheel based resistance. So that pause for a second, take a second to process that. I'm trying to give that example of how we progress or just track what we're doing with gravity-based resistance, and saying it's a different point of emphasis when we're looking at something like a flywheel. How fast or how slow it is, and how long are we taking to go in totality. That's a big change. And we can look at the rate of change as we go through that. The thing that I think is so novel about Flywheel is this interchangeability of that resistance based off the intent which you're moving. And inertia is going to be tied into that rate that we're moving and the amount of momentum we're creating. And the line that we'll take from the research articles, and I have all the research articles listed in the last module or the last lesson in this whole course. Take some time going through it, because it's going to break down a lot of this stuff that I think it just gives you some sort of like context around people who are doing research trying to understand this as well. But when we're looking at it from a low inertia standpoint, that's going to be something related to velocity deficit. And if they are slow, that means they're not producing enough inertia to create enough angular momentum to override the lack there of velocity. And then we can look at it from a high inertia. It's probably someone that has a deficit in terms of force, and they can't produce enough force. And going back to that continuum, heavy, fast, or long, or we can look at it from a velocity or force, velocity, or work kind of component. We start to think about the inertia with Flywheel is looking at low inertia is going to be velocity, so they need to be more focused on increasing the rate in which they're moving. And then we can look at it from a force perspective of high inertia. They need to increase the force in which they're moving with. Now, as we start moving through this, the intensity, therefore, is kind of predicated off of that like inertia that we are creating. So if we look at high inertia, creates high eccentric force. So if I'm producing more inertia, it's going to have a higher eccentric force associated with that. If I'm looking at low inertia, I'm looking at higher eccentric velocity. So that component, you can start to see how that connects, as we talked about before. That low inertia is a velocity deficit. We look at high inertia as a force deficit. And then we can think about the inertia creates that eccentric force, or the rate or low inertia is creating that eccentric velocity. And that component, which is so interesting about this, so let's say you're doing a row and you're pulling it slow. This is a slow movement. Maybe it's a big wheel, or maybe you're just not moving with a lot of intent. And you start to think, okay, start pulling that thing really hard. Really pull. I want you to pull as maximal as you can. You're playing with inertia on the fly, and you're adjusting or being malleable to their deficit right there. With a barbell, the equivalent would be I have to rack the bar, take weights on or off, maybe put accommodating resistance on there. And the beautiful thing about Flywheel is you just say, hey, move further away because we can increase the angular momentum or the amount of force you need to create. Hey, move closer. We could say, hey, I'm just pull it harder. Hey, I want you to pull as hard as you can and not let it go, but let that go towards the actual base of the center of rotation faster and then react to that load. It is this malleable thing, and we can look at it from a work capacity standpoint that we start to say, okay, I'm going to adjust the rate or the size of the wheel that's going to be accommodating to getting 10 seconds or 30 seconds or a minute. And that has a profound impact on just the ability to adapt or just organize itself based off of that person and that group might need. So if you have multiple people working at one flywheel station, the change of hey, we're just going to pull harder or pull with less speed and build up gradually, or we're going to go as hard as we possibly can for a certain period of duration based off the person in front of me. So you're going to go 10 seconds, you're going to go 30 seconds. It just sets up a different context altogether, which is powerful in terms of specifically a group environment. And plus, too, it gets into this. Every person is a beautiful individual snowflake, and they come in to train every single day with a different set of readiness, and you can be more flexible with your periodization, just saying, hey, I want you to go as hard as possible for this set period of time with this size wheel, and it auto-regulates the amount which they can go because there's a governor, and that governor is them, not necessarily the tool, which is a complete reversal of the way we should be thinking about loading our athletes or clients. Volume. Greater distance from the center of rotation increases inertia. So if I'm further away from that flywheel base, it's going to increase inertia. Higher inertia is associated with higher work. So if I'm producing more inertia, I'm going to have therefore a higher work, which is force and distance or force and duration in this case, or the both, right? So we could think about that. Hey, I want to increase the work I'm doing, just get them further away or have them go longer. Then we're looking at the volume again is dictated by increase the distance per rep, increase the number of reps, increase the duration of reps, or combine distance, reps, and duration, right? And that, hey, now we're working on intensity through volume or through velocity, and now we're looking at volume through duration, distance, and repetitions. And all of those are interchangeable. And we can just start to now build our programming, which is going to be something you're going to work through or substantiate the level of stress that we want to impose to our athletes right then and there. But it's not as binary as, hey, they squatted 400 pounds, so I can associate that, relatively speaking, to their 1 RM, because it's more fluid and more reactive to what the rate or the amount or the intent they're putting into it. And the thing that becomes very apparent is they have their own internal governor, which is the opposite of what gravity-based becomes the limiting factor. But as we're starting to break down, going back to this, like you got velocity as intensity for inertia, and then we're looking at duration or distance or total repetitions, which is kind of going into that duration as your kind of marker for volume, and you're starting to look at where the deficit is. So is it a force problem? Is it a velocity problem? Or vice versa? And if it's a force problem, okay, well, I got to think about what timing or what inertia I need to create to decrease that deficit. If it's a velocity problem, how fast do I need to be going and how much inertia do I need to be creating to decrease that velocity? And from a profiling, going back to what we talked about the last presentation, is that simple fact of, okay, there's this surf in the curve, force velocity, the inversion of force and velocity, and we have to almost pick a horse before we start training just from the logistics associated with it and the point of emphasis. That's more fluid with Flywheel. That I know the problem that I'm working with. I'm looking at this athlete in front of me. They have a force or a velocity deficit. I need to improve this component of that. And I don't have to essentially pick a horse. All I'm going to say to that athlete is pull or push as hard as you possibly can for this set period of time from this distance away from the center of rotation. Like, that's pretty powerful if you think about it. And the idea is, how do you progress that over? Okay, we're going to increase the rate in which we're moving, or we're going to increase the duration of what we're doing from week over week to further close that gap and be more respective of what that athlete needs in that time. Okay, we're going to stop there. We're going on to multiplanar, multi-vector. I think this is going to hopefully close some gaps. I know probably right now your head's spinning and you're going, okay, well, I'm having to go back and Google and look at inertia and angular momentum, angular velocity. That's exactly what you should be doing. But the the practical component will hopefully tie a lot of this stuff into where you need to be looking, because that's going to be a huge component of this, relatively speaking, than just the periodization or the programming or the inventorying or the profiling, what we need to look at. Because the actual being able to see the destination of what this feels like in practice, that will make the biggest difference. All right, let's get on to our next lesson.